Is asking us to find how high a ball traveled after a baseball player hit a pop fly or fly ball. So what we're trying to do here is figure out this distance delta x to the maximum height here. It gives us remarkably little information. In fact, the only thing it actually says to us is that a time it gives us is 3 seconds. So looking at that, we have to actually think about this to see that the time is actually the time it takes for the ball to travel up and then come back down. Like we learned in class, as soon as the ball leaves the bat, it's being acted on by it's only under the influence of gravity. So it's actually going to slow down the entire way it up until it stops for an instant and then travel back as it speeds up going down. The whole trip, it will have a constant rate of acceleration. And that acceleration, like we learned yesterday, is g, or 9.8 meters per second. And gravity always acts down, so this is something that we sort of assume in a problem, where g is equal to, I'm going to make it negative 9.8 meters per second squared. Now, what this negative means, and this is a really important thing, is choosing a sign convention. What I'm saying is down is equal to negative, because I'm choosing that. And what I'm implying by that is up equals positive. So these are all vector quantities. If I don't include the negative, then the equations don't know, is it going up or is it going down? So I'm going to put in that negative sign because I've chosen down to be negative. The other thing we kind of have to infer from the question is that at the very top, the speed, so this ball is hit very fast. It's traveling with a pretty high velocity initially, and as it's going, it slows down until at the very top, it's going to stop. So what we can say is the velocity at the top is equal to 0. And what we're going to do is just break this problem up into two halves, the going up and the coming down. And one thing that may not be intuitive at this point is that it's a symmetrical process. So it takes 1.5 seconds to reach the maximum height and 1.5 seconds to get back down. So knowing that, we can start plugging in some of the stuff we know and we don't know and we want to know. Delta x, delta t, v naught, v, and a. So we've already decided that our a is negative 9.8, gravity basically, meters per second squared down. We don't know our initial velocity, but we're calling our final velocity. We're really just looking at the first half, and we're saying it reaches 0 speed at the very top. The time is going to be half of 3 seconds, which is 1.5 seconds. And what we want to find out in part A is the maximum height, or delta x. So you can see that this is the only thing I don't know and I don't care about. Remember, that's what we're trying to do. We're trying to find 3 pieces of information. One of them we want to know and the other one we just don't care about. And that's the one. We're going to choose the equation of the 5 that does not have v naught in it. And that equation is delta x equals v delta t plus minus 1/2 at squared from the sheet. All right, let's just plug in the information we know. Well, v is 0, so this whole term is going to go to 0. So I'm going to be left with delta x equals negative 1/2. A is negative 9.8, and then delta t is 1.5 squared. Plug all that in, and I end up with approximately 11 meters. And you can see that it's negative times negative, which is positive. Again, that positive is going to imply up. And that makes sense because what I'm saying is this is actually, delta x is actually a displacement. And what it's saying is, at the end of this time interval, by the time the velocity has reached 0, this ball has traveled 11 meters up. Okay? And so the answer to this, and so in this case, since we're only looking at half of it, the distance traveled is also 11 meters up. So the ball travels 11 meters. And I don't even have to say up because it just says how high does it go. Or the ball goes 11 meters high is fine. Okay, now the thing that, now part B of this problem is asking us to solve how fast is it going initially. And really it's the same problem, it's just that I have a different unknown. So I'm going to do the same thing again, delta x, delta t, v naught, va, and I can sub in what I know, still negative 9.8 meters per second squared, still 0 at the top. This is now my unknown because it's what I want, what the question is asking me for. The time is still 1.5 seconds. This time I can just call this my don't know, don't care. I do know it, and I did care about it, but now I don't. So I'm going to pick the equation that doesn't have delta x in it. And that equation is just v equals v naught plus a delta t. And in this case, what I can do is just rearrange to solve, because we're trying to solve for v naught. It's just going to equal v minus a delta t. So subbing that in, we get, this is 0, we get negative 9.8 times 1.5. And plugging those numbers in, we see that it's 14.7 meters per second. Positive, because negative times a negative is positive. Again, what does that imply? It implies up. Does that make sense? Yeah, because the initial velocity is in fact up. So then we can just say, the question is asking, how fast was it going? It was going 14.7 meters per second up. You can say up, but it's not critical to say that.